Alright, so hello and welcome. Howdy. We're live here. And I would like to continue our, foray into to the wonderful world of Java. I have not been in the world of Java for quite some time. And so it's interesting to me to return. And so, yeah, we're basically just going to try to, the goal is to work on the various Java questions that are on Hackerrank. That's what I'm going for here. And we'll see how this goes. We will see how this goes. Java strings. String is traditionally a sequence of characters, either as a literal constant or some kind of variable. The exercise is to test your understanding of Java strings, a sample string declaration, string my string, hello world. The elements of a string are called characters. The number of characters in a string is called the length, and it can be retrieved with the string.length method. Given two strings of lowercase letters, English letters A and B, perform the following operations. Sum the lengths of A and B. Determine if A is lexicographically larger than B, i.e. does B come before A in the dictionary. Capitalize the letter in A and B and print them on a single line separated by space. Capitalize the first letter in A and B and print them on a single line separated by space. The first line contains a string A, the second line contains another string B. The strings are comprised of only lowercase English letters. 3 lines of output. Sum A and B. Second line, write yes if A is lexicographically greater than B, otherwise print no instead. Third line, capitalize the first letter A in both A and B and print them on a single line separated by space. Hello Java, 9, no, hello Java. Okay, let's go for it. So, first line is the sum, right? Print the sum of lengths. A.length. B.length. Check or print yes if A is lexicographically greater than B and no otherwise. If A greater than B, yes, otherwise no. And finally, capitalize first letter of each of A and B and print them both same line space separator. So we're going to say string cap A, cap B, cap A of 0 equals upper. Now there's, we're going to just say upper. Cap A, 0. Same thing for cap B. Now I wonder if this actually works, what we're about to do. And we're going to system.printf, .out.printf, formatted string with cap A, cap B. We're going to say string 1 space string 2 with a new line character. And we're going to say Java uppercase. It's got to be some function to uppercase method. Yeah, okay. Oracle. Oh. Case or upper takes a character expression as a parameter, returns a string in which all alpha characters have been converted to uppercase. Character expression, if the character type is character, return type is character, otherwise return type is marker. Yeah, so this looks like a database function. Yeah, SQL, I don't know why. JavaDB, okay. Not really what we're looking for. TLDoc, it's interesting. TLDdoc. Output generated. Not really sure I fully understand. All the characters in the string uppercase using the rules of the default locale. Interesting. Okay. Character to uppercase character. That's what I'm looking for, by the way. Character to uppercase character. Yeah. Okay. See what happens when we run this code. Array required but string found. Bad operand types. Interesting. So we cannot simply perform lexicographical. Okay. Lexico. Compare to. Okay. Well, there you go. A compared to B, if that's greater than 0. Okay. And then can we modify so you can use byte arrays, which are like character arrays effectively, to create the string. It decodes the bytes as characters effectively. What we want is, yeah, character at. So we want to modify. So it's interesting you can't modify strings like arrays. I think in C++ you can modify strings like they are, as if they are arrays. What I want to do is change the character replace. There we go. Trim value of. Really? So we can't modify. Are they immutable? Oh, that's interesting. So maybe we need to construct a new string. Well, we can create a character array of the previous string and then modify. But we cannot seem to actually modify a character directly. Formatted string. Oh yeah. The formatted string, it's kind of interesting. We went over that briefly. But I don't actually remember what it does. I guess it's a number formatter maybe. No, not a number formatter. It's... I don't know. Oh, it's static. Ah, okay, that makes sense. Never mind. Okay, I get it. I get it. Excuse me. Copy value returns a string that represents the character sequence in the array specified. Interesting. Concatenate. I mean, you can get the character in the first spot and then concatenate the subsequence. You can do it that way. Can you concatenate? Yeah, I think I'd rather just get a character array and then convert that to a string. Two character array. I think I'd rather do it this way. Let me say A or cap A. Yeah, there we go. Now we do cap A is 0 equals. And then now we can say S string of cap A, BS cap B, and then we can use S and S. Something like this. Let's see what we get if we do that. Compilation error. Can't find symbol. Oh, create a new string. How about that? Oh, it works. Okay. Interesting. Let's go for it. See how we do. Hey, got there. Not bad. Not bad at all. Interesting that you don't get too many points for that. It's kind of involved. Not too involved, but involved enough to be interesting. Okay. What's next? Given a string S and two indices start and end, print a substring consisting of all characters in the inclusive range from start to n-1. You'll find the string class substring method helpful in completing this challenge. No kidding. The substring method, by the way, not the substring method, the KMP is the is a substring search function. Yeah, it's kind of a challenging function. The KMP, Kenneth Morris Pratt algorithm is an interesting one. First line contains a single string denoting S. The second line contains two space-separated integers denoting the respective values of start and end. Second line contains two space-separated integers denoting the respective values of start and end. Okay. Output, print the substring. Okay, well this should be relatively easy, right? Inclusive start to end -1. Yeah, I mean this is just the substring function. I think that's it. This maybe is should be 5 points. I think so. And before it's 10 points. No points? Do we get any points? That should be 0 points. Oh, 5 points. Okay. What happened? Okay. There we go. We didn't get our points. It's like, what happened? We define the following terms: lexicographical order, also known as alphabetical or dictionary order, orders characters as follows: A less than B, less than less than Y, less than Z, and these are the these are the capital letters rather, and then all the capital letters are less than the lowercase letters, and similarly A is less than B is less than C all the way to Z. Example: ball is less than cat, dog is less than dorm, happy less than happy, and zoo less than ball. A substring of a string is a contiguous block of characters in the string. For example, the substring of ABC are A, B, C, A, B, B, C, and A, B, C. Given a string S and an integer K, complete the function so that it finds the lexicographically smallest and largest substrings of length K. Complete the get smallest and largest function in the editor below. Get smallest and largest has the following parameters: string S and K, the length of the substrings defined. The string plus a new character, where and are the two substrings. What? The string plus a new line character plus where and are the two substrings. Excuse me? First line contains a string denoting S, the second line contains an integer denoting K. S consists of alphabetical letters only. Welcome, sample input 0, welcome to Java, sample input 0, Ava, welcome. So Ava is the smallest, and well is the largest. Exclamation, explanation. These are the substrings ordered. Turn the first, smallest, and the last, largest. And as two new line separated values. Ava, well. Stub code in the editor then prints Ava as our first line output. Well, okay, so this is easy. All right. The reason this is easy is because this can be done in linear time, and you can just search through the strings from left to right. Now my question is, excuse me, we don't want to create, we want to use like a string view type of thing to do this. Let's see if we can, is there a Java string view? Excuse me. Character sequence, character buffer, implements character sequence, so any method that accepts a character sequence we call string character buffer. Already accept character sequence instead of a string, all of the parse methods. Create a character buffer, similar way to how the string view constructor works, you call it wrap. The new buffer will be backed by the given character array, that is, modification of the buffer will cause the array to be modified and vice versa. No copying is going on. Can we use excuse me. Can we use can we compare character buffers? Class, character buffer. The class defines 4 categories of operations upon character buffers. Absolute, relative get and put methods that read and write single characters. Absolute and relative bulk get methods that transfer contiguous sequence of characters from this buffer into an array. Absolute and relative bulk put methods transfer contiguous sequence of characters from a character array or some other character buffer into this buffer. Method for compacting a character buffer, created either by allocation, allocates space for the buffer's content by wrapping an existing character array into a buffer or by creating a view of an existing byte buffer. Byte buffer, wrapping an array into a buffer. Character buffer is either direct or non-direct. A character buffer created via the wrap will be non-direct. A character buffer created as a view will be direct if and only if the buffer by itself is direct. Character buffer is direct, made to be determined by invoking the isDirect method. Class implements the character sequence interface so that character buffers may be used wherever character sequences are accepted. For example, in the regular expression package, methods defined by character sequence operate relative to the current position of the buffer when they are invoked. Methods in this class that do not otherwise have a value to return are specified to return the buffer upon which they are invoked. This allows method invocations to be chained, the sequence of statements. Text subtype. Excuse me. Can, for example, be replaced by the single statement. Oh, okay, interesting. Allocate, append. Turns the character array that backs this buffer. Clear, abstract, compact this buffer compared to flips this buffer. Not sure what that means. Equals, equal, get, relative bulk, get, offset length, destination buffer, character buffer. What does this do? Absolute get, bulk get. These aren't static. These are. That's interesting. Excuse me. It's empty, limit, mark, order, position, put. So I'm not really sure what this means. These things mean. Read, reset, rewind, slice. subsequence. Wraps a character array into a buffer. Wraps a character array into a buffer. I mean, I guess you could just create a substring. You just use the substring every time. It just feels so bad to create the substring over and over again instead of using like a just in sort of a left and right value or begin and end value, left and right values, and then just I mean, I guess that is what it is. I don't know. I don't know if there's really a better way to do this. It matters if we use buffers or not. It might be a little bit better to use buffers. I don't know. I'm not really sure. I think you save. I think you save a constant factor if you use buffers instead of like taking creating a new substring every time. But I think you need to create the buffer anyway every time. So I don't know. I'm not really sure. We can just use character sequences instead of or character buffers instead of let's see. Sequences of remaining elements lexicographically without regard to the starting position of each sequence within its corresponding buffer. Oh, okay. I think I understand. Characters from this buffer into the given destination array. Okay. I see. Source destination. Okay, that makes sense. Source get behaves exactly the same way as the invocation. I see. Okay, interesting. Good wrap. Let's see. How do we get a character buffer? Excuse me. Character sequence, character array, toString. I guess we get the character array of the string. Not sure if this is really good to do it this way, but I suppose we can. So we'll use a for loop. We'll do smallest, largest. Do for int I equals 0. I is less than. It's going to be. It's going to be buff dot size or length minus length minus the so less than length minus the k. It should be right. So if you did, let's say it's 5 characters. And k, let's say the whole string is 10 characters, and you have k is 3. So you would want to be 10 minus 3 is 7. You do index 1 less than 7. You do 6. So index 6, 7, 8. Is that right? 3 characters. 10 minus 3 is 7. 7, 8, 9. I think there's a +1 in there. And the reason why there's a +1 is because it's inclusive. Yeah. So it's less than the length, or it's less than or equal to length minus 1, right? And then that's minus x. It's something like this. It's like, so k is going to be b minus a plus 1, where b is length minus 1 minus a plus 1, which then gives you a is length minus k, but then it's less than or equal to minus k. Yeah, that's really confusing. That's confusing. And then we're gonna say character buffer substring or subsequence. Yeah, substring is going to be I guess it's a wrap again, so character buff, so it's going to be buff dot wrap I want to say get. Is that what we do? Can we do that? Wraps a character array into a buffer. Character sequence into a buffer. Offset length. Yeah, I mean, okay. So this is kind of weird. Camel case seems to be how Java is done. And I like snake case. Okay, so if the substring compared to small is, so if this is lexicographically smaller, which means less than 0, we're just going to set small equal to substring. If substring dot compare to large, if this is larger and larger, alright, and then at the end of it, we're going to return string.printf format, however you want to do that. And we're going to say these two strings, the small and large. We don't need smallest and largest anymore. Something like this, I don't know. Cannot find symbol, character buffer. Buff array should be. Huh. Java.nio. Can we not import? We can't get a character buffer. How's that? Can I put that there? Will that work? Oh no. That won't work. Man. Well, that's alright. They don't want us to use character buffers. We don't have to use character buffers. Excuse me. Yeah, 0 to K I think is what you want. If K is, yeah, if K is 3, you go 0, 1, 2. Yeah, that's correct. So there's something here with the printf. Can we not format? Isn't that the same thing? I guess you can't use, okay. So I guess printf is only for an output stream, whereas format is, let's go for it. Hey, okay. Fair enough. Fair enough. Now my question would be, it's not the most efficient thing in the world. There's probably a way to do this better. That's okay. We don't need to spend too much time. We also don't have access to the character buffer, so I guess it's a little bit harder. string reverse, you get a hint. If it's equal to itself reversed, then it's a palindrome, right? So we'll just say reverse. So I think strings probably have a reverse routine somewhere here. No. Does Java have a reverse function? That's pretty interesting. The C++ standard library has a reverse routine. Can you convert a string to a list and reverse it? Sort. What are the methods here? Yeah, the collections library is a lot like the STL. Copy, empty. Maxmin, replace, reverse. There you go. How can we create a list out of? Create maybe an array list out of a character array and reverse it. What can we do with a string? Get characters. Replace, split, starts with subsequent substring character array. I'm wondering. Maybe we can do something like this. Don't necessarily need. Now I don't know. Okay, we don't have. All right, we don't have the. What's that called? We don't have the. Collections. Oh no, it's in Java Util, we have it. Okay, sweet. I was gonna say we should use collections reversed to do this. We do have it, okay. Alright, let's try this. What we want to do is get a character array. Array of a.to character array, and now we want a array list, or really a list, characters, character list, which is going to be new array list of characters. We're going to say C list, and actually we want to use character array, something like that. And now I want to say, oh, yes or no, right? Okay. We're going to say if, say string ret equals no. If C list is equal to collections reverse C list, return yes, or ret equals yes. And system.out.println ret. Now my question is, there are a few things wrong with this, I think. First off, Can we create this array list? It's not applicable. Really? Actual argument character array cannot be converted to invocation conversion. Void type not allowed here. Yeah, okay, interesting. I want to create an array list out of an array. At all, huh? For each. To array. Can you use? That's exactly what I just tried to do. Seems like going from an array to array list is not the easiest thing. What is code dust? Let's try that. Arrays not as list. Arrays not as list. Collections not at all. Wait, does that actually work though? Oh. No kidding. Really? So we do want to use at all. Okay. We actually want two things. We have 1 and 2. And this is really what we want. Something like this is what we're after. Again, not sure if this is the most efficient way to do this. Wait, what? List character cannot be converted to collection super character. by method invocation conversion. Not be applied to these given types. Required collection found. Oh, I see. Can we do this? How about that? You need to wrap the primitives. I see. Huh. What did, the problem with this is, yeah, how do we want to wrap our characters? I thought you could. You could do that. This is definitely lots of binary search. Copy of range deep equals fill hash code sort. So the problem that I'm having here is excuse me. I think we need to invoke as list, arrays.as list. First, to convert this character, convert to a character array, and then you need, because you need character wrappers to use the containers, you need references, you need wrappers for your primitives, which makes things way more complicated. This is kind of annoying. This is like not like C++ at all. Cannot find symbol. Oh. Yeah, C++, you can use primitives directly in your containers. Incompatible types. Character array, oh, okay. Gotcha. So you get a character array, and then you make that a list, and then now we can create these two. Really, this should be an array list, I think. Well, no, it's okay. That's fine. Can I... Wait, really? What? Come on. No. What is this? Oh, what? That's not. Come on, man. Excuse me. This is so annoying. This creates a list of character arrays rather than a list of characters from the array. This is really annoying. Oh, come on, really? I just want to use the collections reverse instead of hard coding it. Excuse me, I'm writing my own. Is this what we need to do? Do we need to? You ready for this? This is interesting. Alright, we create these two array lists. First, we're going to say for character, really character C in character array. We don't need to go, we can do C array. We're going to take clist1.add C, and now we're going to say clist2. It's going to be clist1, and then we can reverse clist2 and compare clist1 and clist2. Still doesn't compile. Okay. Cannot find symbol. Okay. This is great. Add all cannot be applied to given types. Why? Come on. We need to copy them. That's what we need. Oh, this is funny. You could actually just do 1 and 2 also, that works as well. You can just do that. That's probably, if we're gonna do this, I might as well do that. There we go. Oh, it's wrong. Okay. Of course it is. Should be dot equals. That's why in Java there's that's a subtlety. We also want add. We want copy, I think, collections copy. Let's see that. Not arrays, we want collections. Here we go. Copy destination source. One list into another. So it's destination source. So destination is 2, source is 1. So this also should work. No. Source does not fit in destination. Oh boy. Okay. That's kind of annoying. You cannot, you can't copy while also extending. That's interesting. Excuse me. So we can maybe set the size. Add all. Actually, maybe add all is what we want, or clone. Probably want a deep copy, not a shallow copy. Let's try add all. Let's try that. That might be better. Let's give that a shot. Okay, that works. Yeah, so we could add each one individually, or we can add one from the previous list. The copy is kind of interesting. We can say, we say the size of the constructor. Yeah, initial capacity. So we can say these are both CArray.length. And then we can say yeah, I think that's fine, actually. Hopefully that does the same thing. If I could spell correctly, that would help. Really? Arrays don't have length, they have size. Strings have length, though. Is that right? Please tell me. Do these not have sizes? Oh boy. Hmm. I don't know. Oh. Is this not a thing? Dot length. So you have a dot length. So yeah, okay. So Java arrays are self-aware of their length. C++ arrays are not self-aware of their length. That's interesting. And now we can copy. Destination, I think, is CLS2. What do you mean? Or is it the other way around? Oh. Okay. What? Excuse me? Excuse me? Excuse me? Excuse me? Destination source. what? You what? You what? Well, that's confusing. What is this? 1? No, no. These should have the same sizes. A little bit confused here. 5, 0. No kidding. How is that possible? How is it even remotely possible? We set the length here. Initial capacity of 10. Excuse me. But what's the capacity? Excuse me. Oh, so there are iterators in Java. That's interesting. But where is, like, get capacity? How do we... Ensure capacity. Let's try that. So the size really won't matter. This is a peculiar thing. Cannot find symbol. Do I need that parentheses? I wonder. I do. Not a statement. Source does not fit in destination. they lying? Are they lying? Are you sure? That's annoying. That is annoying. That is annoying. Oh, don't need to copy anything. Can do this as well, and that also works. I don't know, I probably won't use that copy too often if it's not that easy to use. That works. I don't know what this copy routine uses to ensure that one fits in the other. I think it uses the size. I don't think it can use the capacity, which is kind of irritating because it doesn't look like there's like a capacity function like a get capacity method exposed for array lists rather. So it looks like you're kind of stuck. Let's go for it here. All right. Kind of interesting though. Looks like it's kind of complicated to do this. You have a character array, and then you have to add character by character to the array list, and then create another array list of that array list, reverse it, and then check if they're equal. That's the only way to do this with without using, but like if you really want to use the collections reverse function, you gotta go through some extra work here. Alrighty, let's keep going. How are we doing on time? Yeah, been an hour or so. Okay, I feel like I spent a lot of time on that question. Two strings A and B are called anagrams if they contain all the same characters and the same frequencies. For this challenge, the test is not case sensitive. For example, the anagrams of cat, cat, act, tac, TCA, TCA, and CTA. Cat are anagrams of cat are and these. Okay. Complete the is anagram function in the editor. Has the following parameters: first string, second string. A and B are case insensitive anagrams, return true, otherwise return false. So this is an interesting question. You can use a frequency map to solve this. It's pretty straightforward, and I'll show you how it works. Comparison should not be case sensitive anagrams. So, alrighty, what we're going to do is the following. So we're going to use character arrays A. Actually, you don't need to do that. I think you can you do this? Can you loop over strings? So many words just to print something. it's okay, but it's a lot. Not applicable. Okay. Well, you can do character array, right? Two array. Can you do that? Okay. Kind of want to do that. We'll do CA, CB, and we're going to say frequency map is going to be really integer array. Frequency new int array 26. And we're going to say characters C, CA. And we're going to say frequency of, increment this frequency, it's going to be C minus 0, or A rather, and we're actually going to take this character and we're going to say character to lowercase of C. And then we're going to do a similar thing, character C and CB. And we're going to say decrement. And then we're going to say boolean ret equals true. And then if we get here and we say if better Twitch TV. I gotta get rid of that extension. Apparently I need that extension. I might have like a virus on my machine too, I don't even know. And they're just asking for permissions to blow my machine. Who knows? Hopefully not. Should run a virus scanner or something. Yeah, there could be I should get rid of that extension. I didn't even know I had that extension on my machine. Let me write that down. All kinds of stuff I need to do. I can't remember to do all of them, or I don't remember to do all of them. I didn't even know I had that on this machine, but I'll get rid of it on this browser. The tricky thing about this is yeah, that's fine. So we'll just do something like this. We're not going to terminate early. We'll just, well, we can. We can say if x is not equal to 0, return false, otherwise return true. There we go. We don't terminate as early as we could, but we terminate early. Okay. Really? Kind of, oh, chat. Interesting. Is that because just thinking about BTTV. Oh, it worked. Hey. Go for it. Go, 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 go. Alright. That's an easy one too. What do you get? 10 points for that? Okay. So yeah, the deal with anagrams is right. You can build frequency maps and then you add all the characters for one and then subtract all the characters for the other, and that gives you, it should be all zeros in your frequency map. And that shows that they're anagrams of each other. Now the question is, how do we I guess that's it. Yeah, that's probably fine. That's okay. Go on to the next thing. It's fine. Java string tokens. Okay, give it a string S matching the regular expression. Excuse me. Regular expression. This one. Split the strings into tokens. We define a token to be one or more consecutive English alphabetic characters. Then print the number of tokens followed by each token on a new line. Okay. matching this regular expression, split into tokens, one or more consecutive English alphabetic characters. They find the string split method helpful in completing this challenge. You bet. I bet I would. I bet I would. Single string S. S is composed of the following English alphabetic characters: blank spaces, exclamation points, commas, question marks, periods, underscores, apostrophes, and @ symbols. Output format. On the first line, print an integer n denoting the number of tokens in string S. They do not need to be unique. Next, print each of the n tokens on a new line in the same order as they appear in input string S. He's a very, very good boy, isn't he? Very, very good boy. Good boy, good boy. Good boy. We are contiguous segment of alphabetic characters. Total of 10 such tokens in string S, and each token is printed in the same order in which it appears in string S. Oh, didn't mean to do that. Didn't mean to click on that. Okay. So use a regex. Around matches of the given regular expression. Okay. So, boo and foo. These expressions. Boo and foo. Oh. So yeah, I think the delimiter is the regular expression. So it's interesting because we want the non-empty strings basically. Yeah, I guess, well, we want any number of characters that aren't, yeah, okay, we could do it that way. Alright, I have an idea. We just print it, right? So there's a string split. We can say s.split, and the regex we can use can just be not A to Z, and any number, at least one, any number of those. And this will give us a match, string match, yeah. String array matches. And then we can say system.out.println matches.length. And we could say for string s and matches, system.out.println. Actually, you can do, yeah, we'll do it that way, it's fine. S. Let's see what this gives us. Oh. Call it ST. Go for it. Now, this might fail on some test cases. There you go. Okay. I was thinking that it might. That's annoying. And the reason for that, I think, is these I want to say that it's possible to have empty strings here, something like that. Like if we tested this on We could test this code locally, right? Excuse me. Let's see if we can do this. Try to test it locally, see what happens. Whoa. Okay, so quite a bit of different things going on here, but we're going to say vim test. It's going to be test Java. Well, let's do. What is this test Java right now? Yeah, okay. Let's modify this test Java. And let's add whoa. Didn't mean to do that. Okay. Alrighty. Java.util. I think scanner is included there. I don't necessarily know. Oh, missed something here. Okay. Let's see if that compiles. Oh, sweet. Wow. Okay. That's kind of interesting. It'll compile the program and also take this string in here. So my question is, if I put like this, that's the problem. Yeah, I kind of thought that might be the case. Right. Just thinking here. Yes, seen this before. I think you need to trim the string for these other characters first. Yeah. I thought that might have something to do with it. It depends on how the split function is implemented, but if you see a delimiter or whatever you have before you see that delimiter is usually considered a string, even if it's an empty string. So a few ways to address this is like we can try to split in such a way where, because we have to specify the delimiters, right? So we can trim maybe the string, the beginning of the string off. That's one possibility. The other possibility is to actually just ignore the empty strings. But the problem with that second approach is that I think we will need to I think the problem with the second approach is that I think we're going to need to loop through our matches more than once. which I'd rather not do that if we can help it. So I'm wondering if there's a way to trim. Let's go to the top here. Trim. I don't just want white space though. What are some other string operations we can do? Can use a match. Replace first. Okay, you ready for this? We can do replace first. Of this token of the delimiter. So get rid of the first delimiter. Well, that's if that's if it starts with that. Yeah, actually, you know what you should do? You should do the following. And matches. Num matches would be matches.length. Say if matches of 0 equals the empty string is equal to. And we decrement the number of matches. And then we print num matches. And then we just say if st is not equals empty string okay. How about that piece of code? That's a little bit better around this part here. Okay. Alright, let's see how this works. Hey, there you go. That's what we're after. Let's go for it. No, still wrong. Runtime error. No kidding. Oh, there are no matches. I didn't think about that. How about that? I probably shouldn't just keep hitting the button every time. It's not a. That's not a good way of doing things. So yeah, there's some issues here. Not a particularly hard question, but pretty easy to make a mistake. I think this is the best way to do it. You don't have to loop over the string more than once. There really is only one thing, right? It's if the first element is empty, you have to worry about. And you also have to, obviously, if there's no elements, you don't want to be trying to, decrement things. Yeah. You really could loop over the string array. You could actually make this even faster if you change this if statement. Instead of using an if statement here, you can have like a beginning point value, I guess, and you would increment that, and then you would start your for loop at that point. So you would just always skip the first empty one and so you wouldn't branch at all, really. You just have a branch up here and then a loop here, and it could be optimized, I think, to be faster. But anyway, we keep going. Need help? I appreciate that. Thank you. I don't think I do. I don't think that I do. Alright, pattern syntax checker. Using regex, we can easily match or search for patterns in a text. Before searching for a pattern, we have to specify one using some well-defined syntax. In this problem, you are given a pattern. You have to check whether the syntax of the given pattern is valid. A regex is only valid if you can compile it using the pattern compile method. First n of line of input characters of n denoting the number of test cases. The next n line contains a string of any printable characters representing the pattern of a regex. For each test case, print valid if the syntax of the given pattern is correct, otherwise print invalid. Do not print the quotes. Matcat, patnat, valid, invalid, invalid. Okay, so basically if the compile throws, it's pretty much what we're going to use. Pattern syntax exception, yeah. Okay. While pattern code. Try, catch. And that's pretty much it. It's going to be pattern.compile. So compile is going to be static compile, pattern.compile string regex. System.out.println valid. Otherwise invalid, and this is pretty much any exception. It can be a little more specific because we know exactly what the exception is going to be, but we're not going to be. What does this look like? See, we let the regex engine handle this. Your output. Valid, invalid, invalid. No such element exception, no line found. Oh. This actually should just be actually do it that way. Fine. Oh, this is the the goes to operator. As the test cases go to 0, you have your while loop. That's so funny. I haven't seen this operator in a long time. The goes to operator. As test cases goes to 0. Oh, it's hysterical. That's funny. Compilation error. Okay. That's great. We're gonna keep it. It goes to 0. Does it work? I don't know. I'll find out. Oh, it does. Okay. Ah, yes, the classic goes to operator. As test cases goes to 0. Minus greater than. That's great. I'm grateful. It's a good laugh. Class called myRegEx, which will contain a string pattern. You need to write a regular expression and assign it to the pattern such that it can be used to validate an IP address. Use the following definition of an IP address. String in the form ABCD with a value of A, B, C, and D may range from 0 to 255. Leading zeros are allowed. The length of A, B, C, or D can't be greater than 3. Yeah. Valid IP addresses, invalid IP addresses. Oh, I've seen this question a few times now, more than once. It's an interesting question. Provided strings containing any combination of ASCII characters, you have to write a regular expression to find the valid IPs. Oh, okay. Let's write the myRegEx class, which contains a string pattern. The string should contain the regular expression. MyRegEx class must not be public. Okay. Oh, wow. Whoa. String IP next IP matches myRegEx pattern. So confused. In.has next string IP is a string IP matches on myRegEx.pattern. Must not be public? Must not be public. Why? Why does that matter? I mean, shouldn't, what? That is so confusing. Okay, I guess. I don't know. Pattern. Is this what they're after? I'm so confused. I don't get it. Identifier expected. Oh. Okay, it works. We compile. I don't know why this can't be public. I'm not really sure what they're getting at here, but okay. Anyway, so the regex, by the way, it looks like the following. It's going to be digits 0 through 9. It's actually not 0 through 9. It's going to be 3 pieces. Right, there's dots, and it's gonna be actually you don't even need to do that. You can do just 0 through 2, 0 through 5, 0 through 5, and this has got to be, this happens with a dot. Right, this is going to happen 1, 2, 3 times, and then it's got to happen one more time over here without a dot at the end. Something like this. Let's see what happens if we do that. Wrong answer. Okay, all false. First one should be true. Oh, there can be leading zeros or not leading zeros though. Ah, I see. A regex that does this, huh? It could be. I think it's the other way around. It's. Also, yeah. I did this wrong. It's Yeah, this is wrong. It's not. Because these could be 9, these values. I don't know, man. Using a regex for IP matches seems kind of difficult, kind of weird. It really could be any number from 0 to 255, with leading zeros or not. And that's 4 times with dots in between. Anything else won't work. How do we just get 0 to 25, 255, right? It could be a digit from, so we can do this, I suppose. I really like the, I guess you're kind of forced to use camel case with Java. Well, I really do prefer, excuse me. Excuse me. I really do prefer actually, what was I even saying? I really do prefer snake case, but I suppose camel case is the way to go when you're programming Java. So what we want to do is we're going to write a routine to initialize this pattern, and we're also going to we don't have arrays. Come on, man. Come on, man. That's fine. Yeah, we want to copy this. We're going to try to find a regular expression that just matches any number from 0 to 255, including leading zeros. And then we're going to just copy that 4 times and join that pattern and use that. So we want to join somewhere here. And there's split and there's join. Delimiter elements, delimiter iterable. Can we use an array for this? String join. What? That's annoying. can make an array list of strings. Hopefully that works. We don't have array lists? That's annoying. Okay, we can't use the join because we can't get a. That is so irritating. All right, fine. Yeah. All right. What do we get if we do this? Okay, at least that works. Trying to be clever here with my methods here. I mean, trying to use different Java methods. 0.0.0. Yeah, that's what we want. Okay, all right, that's what we're after. All right, perfect. So now we can just try to match from 0 to 255, which is easy, which is relatively easy. So we could do 0 through 9, or 0 through 9, 0 through 9, right? 2 characters, or 3 characters would be 0 through 2, 0 through 5, 0 through 5. Now this is a little bit confusing because you can have 0 or 1 or nothing. 0, 1. So this will give you, yeah. This could be 0 or 1 of these characters. So you have 0, 1 of the characters, 0 or 1. Now if you have 2, the best you can do is 0 through 5, but you could still have 0 through 9 if you have 0 through 4. So 0 through 4 you can do 0 through 9, but if you have 2 and you have 5, then it can only be 0 to 5. That is quite the regular expression. All right, let's print what we have as well. Okay. And it doesn't match for any of them. That's perfect. 0 through 9, 0 to 1, question mark. Okay, well 0, 0, 0. Do we match that? Well, that could be, that would match here. And then 12. That actually doesn't match 12. Yeah, that's interesting. No, this should be no character here, 1 here, 2 here. So this matches 12, 12, and 0, 3, 4. This matches 0, 3, 4. So this actually should match, believe it or not. I don't know why that doesn't match. I think the reason is that you need to have parentheses between these to separate the pieces. Otherwise, this or is not between these pieces. It's actually going to be an or between like the individual characters themselves. I guess I'm not entirely sure actually what's going on here. Okay, still false for the first one, which doesn't make very much sense. I don't know why that would be. Let's do this one directly, right? Let's just say red equals this and see what happens. We want to get at least one match here. Okay, that one matches. For some reason that one matches. Why? How come this regular expression doesn't? That really seems very strange to me. If it was just this part, so what about this? Okay, we got true. Yeah, that's what I was expecting. But for some reason we throw an or in there. That's really weird. Or 0 through 9, right? Somehow this doesn't match anymore. Yeah, okay, that's weird. Why that? Why is that the case? I think these need to be escaped. Perhaps, I don't know. No. No. I don't know if these parentheses, no, they're not. This is how it's supposed to be. Why doesn't this work is my question. Does this or not work the way that I think it does? Why does this not match? Does this whole thing need to be in a parentheses? In parentheses? Why would that matter? Oh, it is. Okay. That seems so strange to me, though. If those aren't in parentheses, then yeah, for some reason that matters. And why would that be the case? Or any of these things. Unless you contain the whole thing in one parentheses, then for some reason this could fail a match. Now that I don't understand. I don't know why that would be the case. I don't know. Not a clue. I think maybe might have to do with how these are chained, these ors. So it's this or this, or this or this. Is maybe it's like this or this, or this or this, something like that. Actually, it doesn't work even if you just have two. So this or that. Well, the dot. I don't understand. I don't know. I just don't know why it doesn't work. Why it fails. Or why that would matter. I don't know. I couldn't tell you. I really don't know. Because you're, yeah, I don't know, man. I really don't know. This should just match everything on this. This whole regular expression or this whole regular expression and a dot. I don't know, man. I couldn't tell you. I don't know why you would need this extra parentheses. No clue. I'd have to really sit and think about it for a while, why that might be the case. That seems like kind of arbitrary. Seems kind of arbitrary. It's got to have something to do with how the regex engine does things. Oh, there we go. Okay, true, true, true. False, false, false. Neat. 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 Got him. Okay, now the question is, we could have 0 through 9, and we can have trailing zeros. They're not. We can have, which yeah, this may or may not be there. So actually, this case is handled as a subcase, right? This would be, 0 through 9 we can have with or without the characters in front. Now if we have a 2, that's when things get interesting, right? We can either have, now we need to have a character, and we could have 0 through 4, and 0 through 9, any number from 0 to 49 inclusive. And then we can have 25, and then that's only from 0 to 5. I think that's it. I think those are all the possible choices. And we had some issue compiling our... Alright, I think we just go for it, man. I think we go for it. Hey, it worked. Sweet. Nice. There we go. Yeah, interesting. Interesting question. I like this question. That's a good one. Really kind of a pain in the neck if you had to do this in write this out in one shot. You might be able to write this expression more compactly, but this is so much easier if you just use the ORs. This is a pretty compact part. It's really compacts things. So okay. Okay, sure, fair enough. Let's go on to the next one then. Java regex 2, duplicate words. In this challenge, we use regular expressions, regex, to remove instances of words that are repeated more than once, but retain the first occurrence of any, case-insensitive repeated word. For example, the words love and to are repeated in the sentence, I love too. I love to code, 20 code. I love to 20 code. Can you complete the code in the editor so it will turn I love to 20 code into I love to code. I wrote code. Solve this challenge. Complete the following 3 lines. Write a regex that will match any repeated word. Complete the second compile argument so that the compiled regex is case insensitive. Write the 2 necessary arguments for replace all such that each repeated word is replaced with the very first instance the word found in the sentence. It must be the exact first occurrence of the word as the expected output is case sensitive. Challenge uses a custom checker. You will fail the challenge if you modify anything other than the 3 locations that the comments direct you to complete. To restore the editor's original stub code, create a new buffer by clicking on the branch icon in the top left of the editor. Oh, okay. Input format. The following input is handled for you, the given stub code. The first line contains an integer n, denoting the number of sentences. First line contains an integer n, denoting the number of sentences. Each of the n subsequent lines contains a single sentence consisting of English alphabetic letters and whitespace characters. The following input is handled for you, the given stub code. I guess in this given stub code. The first line contains an integer n, denoting the number of sentences. Each of the n subsequent lines contains a single sentence consisting of English alphabetic letters and whitespace characters. Each of the n subsequent lines contains a single sentence consisting of English alphabetic letters and whitespace characters. The following input is handled for you in the given stub code. The first line contains an integer n, denoting the number of sentences. Each of the n subsequent lines contains a single sentence consisting of English alphabetic letters and whitespace characters. Each of the n subsequent lines contains a single sentence consisting of English alphabetic letters and whitespace characters. Sorry, I'm struggling to read this for some reason. Each sentence consists of at most 10 to the 4th English alphabetic letters and whitespace. And there's 100 sentences. Stub code in the editor prints the sentence modified by the replace all lines standard out. Modified string must be a modified version of the initial sentence. All repeat occurrences of each word are removed. Goodbye, bye, bye, world, world, world. Sam went on to his business. Rhea is the best player in II game. And in the hello, AB. Goodbye, bye, world. Sam went to his business. Rhea is the best player in I game. And in the hello, AB. Okay, case insensitive. Interesting. So it matches any. Okay. Remove the second occurrence of bye and the second and third occurrence of world. Second occurrence of went. Second occurrence of is, I, AB. Important to note that our matching is case insensitive. We specifically retain the first occurrence. Oh boy. Oh, it looks like you also used the goes to operator. So saying he uses a special. Now I'm very confused. This challenge uses a custom checker. You will fail the challenge if you modify anything other than the 3 locations that the comments direct you to complete. Alright. So write a regex matching words here. Insert the correct pattern flag here. Check for subsequent input that match the compiled pattern. The regex to replace the replacement. Prints the modified sentence. I'm a little bit confused here. I'm a little confused how this is going to work. Excuse me. I don't know how I would do this with or without a regex. This is an interesting question. How would I efficiently solve this in the first place? I don't know. This seems kind of hard to do efficiently because you're looking for any duplicate regular expression, which means basically your regular expression is pretty much changing each time. And what's interesting is this replace all is replacing each match with empty characters. I mean, yeah, you pretty much run through the string multiple times for each duplicate value. So it seems kind of computationally expensive. I don't know, I guess maybe you're given a pretty good amount of time for this. But I want to say this is like quadratic time, which is kind of slow. But yeah, I mean, if it's just one regex, then you would just use the regex here. And you would have the replacement would be an empty string. And then finally, matching repeated words. Now this I have not a clue. Compile. Now there's apparently a compile flag for your pattern. I don't know, man. Also, I think I missed a letter there. Missed a character. Compiles, string regex flags, case insensitive. There you go. Dot all. What does that mean? Unicode case canon equals Unix lines literal Unicode character class comments. Dot all. Dot matches any character including a line terminator by default. Does not match line terminators. Mode can also be enabled via the embedding flag expression. The S is mnemonic for single line mode, which is what this is called in Perl. Oh, okay. Single line means interesting. The dot matches every character. Yeah, normally that would be what I would use, by the way. Canon EQ. Canonical equivalence. Two characters will be considered to match if and only if their full canonical decompositions match the expression, for example, match the string when this flag is specified. What does that mean? By default, matching does not take canonical equivalence into account, and there is no embedded flag character for enabling canonical equivalence. Specifying the flag may impose a performance penalty. Nice. Nice. I don't know what canonical form means. Or canonical decomposition. What is that? Canonical decomposition. Canonical decomposition. What does this mean? Fuzzy classical structures in genuine quantum systems. X, a canonical decomposition of thermal states into pure states. Of course, that's exactly what I was thinking. Excuse me? A canonical decomposition of magneto-telluric responses. Oh man. Strings. What does that mean? Unicode normalization. Okay. Unicode normalization forms. Specifications for 4 normalized forms of Unicode text. Equivalent text, canonical, or compatibility will have identical binary representations. When implementations keep strings in a normalized form, they can be assured that equivalent strings have a unique binary representation. Okay, I think I understand. Unicode standard annex forms okay, well, where's 2 equivalents between characters, canonical equivalence and compatibility equivalence. Canonical equivalence is basic equivalency between characters and sequences of characters. Following figure illustrates the equivalence. Fundamental equivalence indistinguishable to users when correctly rendered. Includes combining sequences, Hangul, singletons, Hangul, singleton, I don't know what Hangul means. For round trip compatibility with existing standards, Unicode has encoded many entities that are really variants of existing nominal characters. The visual representation of these characters, particularly a subset of the possible visual representation of the nominal character. These are given compatibility decompositions in the standard. Because the characters are visually distinguished, replacing a character by compatibility equivalent may lose formatting information unless supplemented by markup or styling. See the figure below for examples of compatibility equivalence. Okay, so there's a compatibility equivalence and there's canonical equivalence. And canonical equivalence basically means there are Unicode characters that are equivalent to other characters, and you could find yourself in a situation where the formats are, the Unicode format is different, but they're equal characters. Okay, that's really interesting. So that's canonical decomposition. Okay, canonical equivalence. Wow. Don't really need to use that though. That's not entirely necessary for us what we're doing right now. Case insensitive. Okay. Let's see. Enables case insensitive matching. By default, case insensitive matching assumes that only characters in the US ASCII character set are being matched. Unicode aware case insensitive matching can be enabled by specifying the Unicode case flag in conjunction with this flag. Case insensitive matching can also be enabled via the embedded flag expression. Specifying this flag may impose a slight performance penalty. Interesting. Alright, so we can just say case insensitive here. And it's pattern static, right? Excuse me. Yeah, public static final. Insensitive. There we go. Case insensitive. Alright. Okay, we got that much. Now the regex though. A regex matching repeated words here. How do you do that? Oh man. Whoa. I guess you'd use the look ahead. Of some kind. I really don't know. I have no idea. Quite frankly, not a clue how this would work. I had no idea. I don't even know how I would do this with or without a regex. Duplicated words. Well, I guess it's just any word, really. If you match any word, you would remove all of the other words using case insensitive matching. Yeah. What does this do? This find, this m.find p matcher input. That might be it. Maybe that simple. You just match the first word, and that's it. Let's try that. Let's see what happens when we do that. That might be that simple. You just match any character. We said dot question mark S, right? We could say that really doesn't make a lot of sense, does it? You could do something like this. Well, I want to say like you can match you could do something like a word and some look ahead copy of that word, and then when you replace in the string is the first part. So you could use like a look ahead symbol, like a look ahead match, something like that. Just want to see, what does this do? There's a find here. Attempts to find the next subsequence of the input sequence that matches the pattern. And then the method starts at the beginning of the matcher's region, or if a previous invocation of the method is successful and the matcher has not since been reset, at the first character not matched by the previous match. If the match succeeds, and more information can be obtained via the start, end, and group methods. Okay. True if and only if the subsequence of the input sequence matches the matcher's pattern. So the thing that's tricky about this is we're replacing all of the matches which is a little bit confusing. P.matcher of input. Where's P? P, compile this regex. We'll create this matcher on this input. That's M. And now we find from this pattern this matcher. Find on the input. And we replace all. Now, I think we could change this part. I actually think what's weird about this is if we replace all, right? How is this matcher going to work properly? Doesn't the matcher need to go to the beginning again? I don't know how to do this, man. How is this even possible? If you run replace all, I don't know, man. If you replace all and you run this matcher, like what is going to happen? My thinking is this, right? My thinking is just basically you match pretty much anything and a look ahead with anything in between, where it's case insensitive, the look ahead. And then once you've matched, then you replace all of the things you found. See, this is so confusing. I don't know, man. I don't know. What does replace all do? I don't know. Okay. Okay. Regex replacement replaces each substring of this string that matches the given regular expression with the given replacement. Alright, so I guess that's not too bad. This regex actually should be... So if we go back... Ah, okay, I see. I see what we did. Okay. Yeah, this actually isn't regex. Wrong. What it's going to be is this it doesn't really matter, this pattern. We just want to match the first word, really. And then we're going to replace everything that's not that word, that first word. How do we skip the first word? Yeah, really just have to match the first word, and then this will replace all the other words. And I want to do it in a case-insensitive way. I don't know if that's... and just skip the first word. That'll do it. I mean, that'll work. But the question is, how do we do that? Yeah, we can use a .all flag, really. Not even dot, yeah, .all. This one's got to be case insensitive, these matches. But not the first one. That's the only thing. Huh. I don't know, man. This seems too hard. There's so many questions that I have. Like what happens to the matcher if we change the underlying string, the input underneath, which is what we're going to do. Does it just start to find at the beginning again each time? Assuming that's the behavior, then I think we have something of an idea of what we can do. But this is kind of hard because you need to want to replace all of these, but how do we do that? I guess you could, no. I was going to say you could replace all of the other ones with something else that you're going to remove later, but that doesn't really work. You know, you want to replace them. You want to replace them, I think, with the empty string altogether. But the question is, how do we do that? How do we skip the first string and replace all the other strings? I mean, I guess you could. Could do like a fold expression type of thing where you match this thing that you're looking to match twice, and there's characters in between, and you build this string that you replace it with, which preserves the characters in between, but removes the second string. You could do something like that, maybe. I don't know if that works, but we could try it. So basically, you would have dot all, and then you say we're going to dot all, and we're going to find any string that has a space following it. So ignore white space, right? How would this work? Letters in white space, okay. So there's any amount of white space, and there could be any amount of white space in front, but we want this middle portion, right? I can actually go ahead and test this locally, which is not a bad idea. Kind of like to do that from time to time. Actually, a neat trick you can do is you can do that. If you wanted to quickly jump from parentheses to parentheses, you can use this % symbol. But anyway, so these anyway. I don't know why. Anyway, okay, it's fine. Okay, So we have this main, we have, this comes out down that way, this is entry point, this is main, regex, pattern, compile, new, scanner in, parse, number of lines, and we run this replace all, and the replace all, this regex can be whatever. We could just do m.group of 1 or 0, yeah, 1, and okay, illegal escape character. So I don't know what the white space character is in Java. In Java's regex expression, or regex engine rather. Is it S? Okay. Illegal escape character. Oh, why is that? Also, not enough regex is util. It is okay. Sure, we can go to Java 7 or something. Java 8. Oracle. Can we, is there a way to go to Java 8? Alright, how do I search this? Index. Regex, or even just pattern. Yeah, well, that's fine. Java util regex should be fine. Okay. Sure. Here we go. Okay. So why, what is the issue then? It's saying an illegal, I don't know what that means. Cannot find symbol pattern. Pattern. Pattern class matcher. Class pattern. Why though? You have right here, Java util regex, Java util regex pattern. Is that why? I just need to specify it explicitly? Do you just need regex.pattern? No. Interesting. Maybe that's it. Yeah. Also, hopefully you guys don't hear that noise. You don't. Okay. Regex does not exist. Okay. Mm-hmm. Interesting, but I kind of just want everything in the... What did I just do to... I don't know. What is that? Cannot find symbol dot all pattern. Really? Interesting. Interesting. Ah, okay. So there's no underscore. At least not in this program. Oh, I see. Okay. Java test Java. One. Hello world. Hello. And it prints hello. Okay. Interesting. So we get hello, and then what we want is some amount of white space, really any number of characters, and then -1, and we want to do something like this. I see why I get that noise every time. Hello, so one hello world, hello. Okay, interesting. What we want to do is remove the second hello. So we want the regex pattern really. Yeah, so we would replace the same, it's the same regex pattern, but we want to replace it with the second part, really, or the first part. And the first part, oops, and yeah, we don't want to include the second instance, more or less. So we would match same regex, same whole thing, but we're only going to use m.group. So I think it's the second one. Maybe, I don't know. Oops. One hello world, hello. Okay, not what we want. What is this second one, maybe? Or is it? It's the second pattern. I think the first one is the larger one, the second one is the smaller one. And so we want to replace this with the first. see. Okay, I keep doing that. All right. Let's do this. Let's system.out.print line of m.group0. So we know what we're working with here. And did that wrong. One hello world hello. Okay, that's not what I was looking for. So m.find just doesn't match anything. That's basically what's being stated here. Okay, I get it now. So if we exclude this, and we exclude this, and we exclude that, then can run this test.java. No group 2. Okay. Oh. What? Oh, I see. How come? How do we have a new line character? I don't know how to. Huh. Okay. Hello world, hello, hello world, hello world. Okay, so only one printout. We have hello world, hello, and I end up with hello world. And we finally print the modified sentence. All right. So check group 0, group 1, and then the result. So group 0, So this matched everything. This matched any amount of white space, some amount of characters, any amount of white space, some amount of characters. Okay. What? I think it's got to be any amount of characters that's not white space. Hello world, hello. Okay, and then hello, hello. So what we want to do is we want to match something that's not white space, that could be surrounded by any amount of white space, that to the right of it there is some white space. And then there's just any amount of characters to the right of it. We want to also match that first group. And then what we're going to do is we're going to replace that first, so we have two groups now. I don't know which one's the first group, which one's the second group at this point. Whichever one is this one, we want, that's what we want to match in the second part. So let's say, so I think we end up not matching anything, right? Yeah. Let's do 0 here. Let's do 1. Okay, so that becomes kind of an issue, right? Because that just doesn't match anything now. This is a look back symbol type of thing. Okay, we got hello world hello is the first, is group 0. Group 1 is hello world hello. Group 2 is hello hello. So 0, 1, 2. So 2 is the one in the middle. Okay. Now what's strange about this, right, I think with the odd part is that we match any number of characters after words. And really what we want to match is any number of characters until we get to 1 again. Oh, excuse me, no. It was 2 before. Hello world hello is 0, hello world hello is 2 is 1, hello is 2. Yeah, it's kind of what I thought. But what's weird about this is we don't match anything now. Now why is that? No, maybe if we remove the well, this definitely won't match anything. Yeah, see, that's really bizarre. We can match hello and then some white space after hello, and that'll match here. And then we want anything until we get to our second match, right? It really could be anything here. But for some reason, this doesn't match anything now, which is so bizarre. And I don't understand it at all. How do we match anything? We just want, excuse me, we just want to match something and then match itself again. But somewhere in between, right? Can we do something like this? So we're just looking for something that's not white space and then has anything in between, and you find itself again. What was matched? No, it doesn't match anything. For some reason, this doesn't match anything, which is the most bizarre thing to me. How come, though? Why not? Yeah, this is so strange. Check, hello, hello, exception. No group 2. Excuse me. Now, what's really weird is actually, I don't know if we're accessing these groups correctly. Maybe that's why. I'm trying to figure out what the problem is. The back reference constructs. Oh, there's not a back reference? What? Excuse me. What? Oh. Perl 5. Pattern engine performs traditional NFA-based matching with ordered alternations occurs in Perl 5. Not supported. Predefined character classes. Back reference constructs. No. Excuse me. These are always back references. Backslash escape number greater than 9 is treated as a back reference. At least that many sub-expressions exist, otherwise the interpretive possible as an octal escape. In this class, octal escapes must always begin with a 0. In this class, 1 through 9 are always interpreted as back references. Always interpreted as back references, and larger numbers accepted as a back reference if at least that many sub-expressions exist at that point in the regular expression. Otherwise, the parse will drop to. Oh, so we can use. We can use back references. All right. So yeah, that's how you use the back references. But the problem is, it doesn't seem to be working. If we modify our test case to something else, hello, hello. right? And we oops, didn't mean to do that. And we had a back reference. Whoa. Yeah. First test case, not. Oh, second test case doesn't work either. How come the second test case doesn't work? How come this doesn't match? But there's a back reference. What do you mean? What do you mean? I'm so confused. Okay, so the second one doesn't match either. No, that doesn't make any sense. That doesn't make any sense now. How is it possible that this regex doesn't match even the second one, right? There's a back reference here. Excuse me. This doesn't make any sense. This doesn't make any sense. What do you mean? How is this not possible? How is this possible? How is this ignoring the back reference? Oh, how do you even use a back reference then? How do we even... you can't... You gotta be kidding me! What is this? What is this? What do you mean? How about the second back reference? How about that? It doesn't work. I mean, 0, but that doesn't make sense. No, nothing matches. No, I can't seem to get it to match anything. What? What? Okay. If I remove the back reference, it's fine. It matches all kinds of things. Losing my mind here. No group 1. Okay. Check hello. So we get something. Okay. Check hello, hello, check world, world, check hello, 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 check hello, hello. Okay. Excuse me. Now, what I'm wondering is, can we please just match something with a back reference? How does that even work? Can we do this? Can we do hello back reference? No, does not match. Are you kidding me? What do you mean? What? What? Ah. Excuse me. Well, I don't know, man. How does it even work? How do you not? What is going on? Regex engines are always a pain in the neck. I shouldn't say they're a pain in the neck. I shouldn't say that. Just say regexes have always been like just frustrating for me. All right, we want to do a match. Match of regex, and we want to use this regex, and we're going to match this string. Hello, hello. And how do we just perform regex matches? Riley and Associates, 1997. Wow. From 20 years ago. No kidding. Can we... I'm not trying to use the pattern or the matcher. I'm trying to just perform... Oh, maybe that's what we need. Just perform a match. Don't want to compile this. I just want to use... I think the string class just uses regexes, right? If we go here, we have somewhere a match. Let's replace all, replace first, split. I'm looking for matches. There we go. Okay, that's all we want. We just want matches. That's it. We don't need all these other things. So it's not mega regex, it's matches. Okay. Nice. String. It's going to be hello, matches regex. False. Come on, man. Why? Why doesn't this match? What do you mean? What is going on? How do I, do I need to, is that why? Wow. That's why I need to escape this. Driving me crazy with this. Okay. True, check this, hello world, hello, check hello, 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 hello. Okay. Now we can try to add something like this here. Okay. Hello world, hello, hello, check hello, 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 hello. Okay. Now I don't feel so crazy. There's just issues with escaping things. All right. Now what's really interesting is this, I think, is now 2. Still true. Hello world, hello. World, hello world, hello world. Right, now that's interesting. Hello, 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 hello. We want to print 2. And we don't need this anymore. Okay, now we're matching things. All right. So 0, 1, and 2 would be hello world, hello, hello world, hello, hello world. Check hello, 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 hello. Okay. Because what we want to do is we want to replace what we matched with only the first group and not include the second group. And I think that's all we need. I think after that we're in good shape. So if we, I think this is it. I think this is the solution. Just, it's just, this brutal, man. Hello world, hello. Yeah. Now where are these? Yeah, I think that's actually all we need. Okay. Okay, great. Sure. So here we're going to say any number of things afterwards, and then 2 is actually the inner one that we want to match. So it should look something like this. And there's one more issue too, which is we actually want also to be case insensitive. Re-gam, e-gam, e-gam, gam, b-gam. Hello. Interesting. Insensitive. Okay. Sam went to his. So my output is interesting. Expected output. So goodbye, bye-bye, world of the world. What is going on here? Whoa. Interesting. That is not what I was expecting. Save some number of characters. You can have some white space here. Some white space, any amount of white space. A string, and then anything else really. And then this back, this case insensitive, match. and you're going to match, and then you're going to replace every instance of this with itself, but not with no longer containing the second match that was found inside here. That's the idea. That should be group 1, is this part. So it just doesn't work on this one. So what happened? Let's go to our program here. Goodbye. Bye-bye, world. Let's try that one. Let's go with that one first. Goodbye, bye, world. Okay, that's not what we want. Oh. Okay. All right, so this is incorrect. So goodbye by world would not match anything, right? So then we would try to first, I think our first match would be by, right? We should have by. I guess we could kind of match this as many times as we want. The tricky thing is we want to replace, like, how do we want to I mean, I don't really know. I guess we have any number of instances of these things. If we did this, what would happen? Goodbye by world W. I really don't get it. I don't understand how we got the O was removed here. That doesn't make a lot of sense to me. Any amount of space, something that's not, and some space. So it doesn't matter as long as there's space on the right side, and then something to the right of that could be anything. And we just remove the second instance there. Good world. Okay. So the by all deleted, and then world only one of them was kept. Okay, that's not what I was expecting. We can you can print the input after, I guess. So back to the drawing board we go, because I do not know the answer to this question. Goodbye, bye. So the world is, wait, how, excuse me? What is going on? So world was deleted, but then good world was left, and bye was removed. And then at the end of it, good world was the last thing that. So what's interesting is it seems that this matcher will operate on the entire. Okay, I think I understand. So the underlying string that this matcher was created on does not get modified. I think that's the case. So that means we really just want to replace all of the duplicates that aren't this first. And this is really weird too, because somehow we removed oh yeah, no, that's so confusing. Yeah, somehow we removed world from our input, and then we added it back, which is so odd. We added it back, and I think the reason we added it back is because this part here, this replacement that we did, actually added it. Yeah, I think it actually somehow added it back, which is really bizarre. Yeah. But what I think we want to do is match anything that has a duplicate, and then replace all the duplicates with nothing, I think. But the problem with that is we only want to reduce it to 1. We don't want to remove all of them. Like, we could do something like this, which would be kind of interesting, an interesting way to do it. And then just have 1, and then replace all of the. Yeah, well, actually, you could do it this way. This actually might be the right way to do it, because now you have everywhere you see 2, you replace you replace it with just the first one, really. Yeah, I think that actually works. What does this do? Girl, hello. Not quite. You need to have at least a 1 white space character, I think. Right. Goodbye, bye. Good world, good world. That's so confusing. And there's a bunch of hellos. Should probably print the first one. So goodbye, bye. World, and then now we had goodbye, bye, and then good world, good world. So bye was removed, and before that we had all the worlds were removed. I don't know how to do this, man. I don't know. It's challenging. We want to remove this is so hard. Also, how does the replace all work? Maybe that has something to do with this. Which one is the regex replacement? Place each substring of the string that matches the regex with a given replacement. Okay. So the matches for the regex get replaced. All right. Could be anything though, this regex. What? We want to find. We want something like this, right? Where we can print sort of the two different groups, right? We could print these groups. This is kind of hard, man. This is kind of hard. So goodbye, bye, bye, world, world, world. We matched bye, bye, bye. Okay. And then this other group is bye. So what's interesting about this is that this does need to be, we want to somehow enforce that the thing we match is a whole word. Which I don't really know how to do that either, by the way. I have to think about that. But even still, right, we would just want this to be bye at the end of it. And so now we have this goodbye bye. I don't know how that even happened. I don't know. This world, world, world is the next match. Should just be world, but then we have good world. Right, so 1, 2, 3, 1, 2, 3, and then finally good world is what we print. How we got good world out of that, I don't know. What even happened? How we got good world out of that? First we had goodbye, bye, world, world, world. Matched this matched bye, 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 right? So we had. Yeah, okay, that makes sense. Yeah, we capture all the stuff in between. So that's the full captures, bye, bye, bye. And then I think somehow we need to get that this is the full word that has to match. Like we can't match partial words. I'm not sure how we're going to do that, but somehow we need to do that. And then obviously, right, the group, the last part is bye. And so then we say, okay, we're going to replace everything that matches this regex, which is the bye, 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 with bye. So bye, bye, bye becomes bye. And what's interesting, though, is we got goodbye, bye. World, world, world just disappeared here, though. Right? Yeah, I guess so. So bye bye, goodbye, bye, bye bye bye, bye, goodbye, bye. So after the replacement, we have goodbye, bye. Now, why is that? Well, the part that matched the regex in the string was bye bye bye, and that got replaced with bye. How world just disappeared altogether. That is bizarre. I don't know how this happened. Like, where did we get... What? What? Is it the next thing? I mean... Could it just be as simple as, like... I mean, this is so confusing if it works like this, but... Could it just be as simple as, like, you just match... something that's not white space, and then you just replace everything here with what was matched. What does this do? What does this do? Okay, goodbye, bye, bye, world, matches goodbye. And then replace everything with goodbye. That's great. And then you bye, replace everything with bye. Bye again, replace everything with bye. World, replace everything with world. World, replace everything with world. That's really interesting. That's not what we need. Definitely not. This is not how I would program this, by the way. If I had the opportunity, if I had the choice, this is not how I would do it. So we're going to just remove everything that matches that. Okay, so we say goodbye, bye, bye, world. So everything that matches, not just goodbye, but just anything at all. So really, it should be not the regex anymore. It should actually be what the regex matched, which is group 0. Okay, so we get goodbye, bye, bye, world. Goodbye is what we match, we remove goodbye. Then we say bye, we remove bye, bye. We see bye again, we see bye again, we see world again, right? So we can match one by one. I think basically what we should do is, see, the replace all thing is kind of interesting. So there are two different strings that we're operating on. That's the first thing. So that's kind of good. That gives us some breathing room. The second string, we want to remove all of the duplicates of the full word. And we can just remove all of them, right? Eventually everything gets removed. But that's not really what we want to do. Ultimately, we yeah, I mean, the thing that's kind of funky is that even though we match with like a backtracking thing, so we can do a similar thing here, so that way we understand what's happening here. We could take our regex, and we can kind of go back to what we were doing before, where we said, okay, let's take a word, but also we're going to find its copy somewhere in the string, right? And then what we want to do, we're still just going to remove the first word though, right? But we're only going to remove the words that have some duplicate somewhere in the string. Let's try something like that, right? And you're only replacing, something like this. What does that do? So, oh man, that looks so strange. What did we say? So we're matching something that's not white space characters, so goodbye, and any number of characters in between until we find another match. And then we're going to say we're going to remove the whole match. Anything that matches the entire match, we're going to remove it altogether. So for some reason, goodbye by world. It's the first thing. Then goodbye. So this whole match matched everything here because I don't really know why. I don't really know why this matched everything. I guess it was an O. It's the O that matched. So there's an O, and then anything in between, then another O matched. That was 0. Oh, I see. And then if we and then the second group is not there. So then we took that whole thing and removed it, right? So then we just had G R L D Y. Oh, I see. Okay, I get it. And then the next match was there's no string to match, so there was no other match. So we just print. Let me. This is quite the program, by the way. This is like really not obvious at all how this is supposed to. It's kind of a brain teaser more than anything else. Because if you had to write an algorithm that does this, I probably wouldn't do it this way. I mean, I don't know. Maybe this is fine, but for some reason, this doesn't seem like the way I would do it intuitively. I'd probably come up with something else. Say final output. Doesn't seem intuitive at all. I'm starting to understand what it does, though. So there's nothing for this final output, and this final output has nothing as well. Also, it's time for bed. We would want a whole word, right? So we don't want just any. We want to make sure there's some white space character that's included here. And yeah, that should help. Okay, so goodbye, and string. So okay, so but now we can match by here, and that just gets outright deleted. We have good world, and the next thing is world. Final output is good. Hello world, hello. Match everything on hello world, hello. And we delete the whole thing. So we want to make sure we get the whole word though. Maybe we want something like this. There could be some white space before. Now, I don't know if that actually makes a difference. It doesn't. I want to figure out how to match all of goodbye. How do we match all of goodbye? Well, need to match whole words here. I mean, adding some white space helps on the right side, but on the left side, there's not necessarily any white space. You could anchor it. You could do something like this. So you can do white space and words, or anchored something like this, which is, I don't know what happens here if we do this. Really what we should do is just print all of the groups. I guess it's groups.size or something, I don't really know. See what we get if we do this. Can it be accessed outside package? Oh no. How do we find the number of matches? Group count. Okay, there we go. Oh no. Okay, oh, it works. All right. So goodbye, bye, bye. We get world, world, world. Group 0, group 1. It's world. Group 2. It's world. Goodbye, bye, bye. Final output. Goodbye, bye, bye. Okay. Hello. World, world. Hello. Hello, world. Hello. Group 1 is hello. Group 2 is null. And then final output. So what's interesting is that we didn't match bye bye bye. I think that's kind of interesting. We also didn't match goodbye. So I don't think you can match goodbye the way this is set up. Let me see. Yeah, you could have one or the other. Now I don't know. This should match. This should match bye bye bye. It does. Okay, and then you have world 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 world, and then okay. So let me see if we can get an anchored string. Okay. Character classes. Beginning of a line. Okay. Yeah. So we were right. We were right to put the beginning of a line here. So either we begin at the beginning of the line and it's a complete word, or we have some new line. We have some new line character, or some space character, and actually we don't want that. It's actually even more than this, right? This is actually not part of the pattern that we're matching. And then which of these groups that we match is another question. So world, 1 is world, 2 is world, and 3 is world. So there's 3 different groups that we matched. And so there's 1, 2, and 3. Is that right? Yes, four overall. The whole thing is 1, and then there's should be 1, 2, 3. And one of these has a space in there. Oh, interesting. You see that? So there is a space. 1, 2. Well, let's actually do this so it's clearer what was matched. Yeah, okay, that's interesting. So we had a space that was matched. So you could do something like this. So right, goodbye, goodbye. Group 1 is goodbye. No. Whole thing gets removed. Yeah, that's fine. That makes sense. So it is group 1 that you would match. Yeah, I think so. It's interesting. But you're matching either one or the other here, and the other one, if it's not necessarily from the beginning, it would be just any old string, really, which I wonder if this works too. Like, what happens if we do this? So we match everything. Group 1, group 2 is goodbye, and remove everything right then and there. Bye. Right. So the problem, yeah, we can't actually match on this sort of naked version of this. I wonder if we just get rid of this altogether. What this would look like. So immediately gets deleted. But we could maybe delete only the, or maybe not delete anything, right? Just, I don't know. Just see what gets matched. So we don't match anything again once we do this, though. That's kind of interesting. I don't know what to say exactly. This might actually not terminate. This might crash. This might Stack Overflow. No. Yeah, I guess what's interesting is that even if there was a replacement or the string changes, there's no new match. Like this just finishes here. That's really interesting. What if you did something like this? I don't know. I don't know what to do here, man. I was so confused. Okay. So we removed goodbye, and then you had final output. Because you're no longer at the beginning of the line. Okay. And how about if you're not at the beginning of the line, but you need to have something to the left. Whoa. Okay. Goodbye, bye-bye, world, goodbye. Then you have goodbye. What is removed? You have bye-bye, world. You have bye, which is, you have bye-bye is removed, and then you have world. And it's interesting that the second group is bye. Group 2 is bye. Group 0, group 2. Group 1 is null. That's interesting. Can't really choose which one though in our code. But it is interesting at least. This is so hard. I really have no idea. I don't know, man. I don't know. Our look ahead only goes so far, you know? To figure out that we have duplicates. I don't know, man. This seems impossible. It seems way too difficult with only a few lines of code. One regex. And all we can do is modify this part here. These two parts. This seems way harder than it should be. It's not really an algorithm question as much as it is like a brain teaser, because it's sort of like a trick that you have to do. A regex trick to get this to work properly. Something here that gets replaced. Because if you, I mean, I guess you could match everything in one shot, like everything that has a duplicate, and then remove all of those, but I don't think this is made to do it that way. I really don't know, man. I mean, you match, I'm thinking the look ahead, but that really doesn't work because it just doesn't make sense. My thinking was like, if you encapsulate whatever this is, right, whatever you've matched, and then you have some string further down, and you match this, I think it'll be group 1, then you can replace and actually make, it really would be like this. I don't know. It's a little confusing, but it would be group 2. You match group 2, and then you would replace the whole thing with group 1. So the whole match, group 0 with group 1. Which is really confusing. That's kind of my idea, my thinking. So goodbye by hello world, goodbye by world, goodbye. That matches everything. And then group 1 is everything without the goodbye. And group 2 is goodbye, and group 3 is goodbye, and group 4 is null. So you'd want to replace group 0 with group 1. And the problem with that, though, is that you're just done because you read the whole thing. You read everything already. That's it, you're done. You can't do better than that. I mean, you can't. There's no continuing with the matcher because it matched all the characters already. Yeah, that's a tricky thing. It's like you can go word by word or something like that, but you won't be able to. Once you've read something, that's it. You know, you in other words, if you read past all this stuff in between, then you won't be able to run the routine that you need to run. That replace all routine. The replace all can replace characters you haven't read yet, but the trying to use the back reference actually doesn't work because there's stuff in between that you may need to work with, and you'll have already read them, and that's that. And while this is pretty good, this actually somewhat works. It's not good enough. It's not good enough. Yeah. You can do, maybe you can do like each word, the regex is going to be not the first instance of that word. Yeah, I don't know, like somehow replace everything that's not that word with an empty string. That's kind of what you're looking for. Or replace it with the rest of the string. take a nap, man. I got work tomorrow. Yeah. Maybe you need to use a forward declarator. Yeah, we just need to do, right, what they call that, a forward. What they call a forward reference. Or look ahead. Zero with positive look ahead. Negative look ahead. Zero with positive look behind. Name capturing, non-capturing. So this is okay. Positive look ahead and negative look ahead. Look. I think the look behind was what we need. So pretty much the regex we're gonna make is we're gonna match each word one by one, and then we're gonna construct a new regex based off of that match, which is going to be like sort of like a tokenized thing, and then we're going to create a new string, a new regex, which is going to use a look behind for this thing that was matched, and then a match itself of that string and any number of characters in between. Excuse me. And ideally, what we'd want to do is just replace the match with nothing, right? Basically nothing. The problem with that though is that I don't know what negative look behind. Oh, I think I understand negative look behind, positive look behind. The problem with that though maybe we need positive look ahead. Maybe that's it. We just positive look ahead for this value, and if it's there, remove it. But we actually want to go from it's so confusing. I mean, that would solve. Well, actually, the problem with that though is that we would be removing the duplicates from right to left rather than left to right. Well, do we remove them left to right or right to left? What if we do A, B, A, right? Does the A on the left get removed or the A on the right get removed? Is there an expected? Oh. 1. But what is the correct output? I don't know what they don't have enough test cases for me to know. Excuse me. Match any repeated word. Compile argument so that the compiled regex is case insensitive. Write the 2 necessary arguments, replace all, such that each repeated word is replaced with the very first instance of the word found in the sentence. Must be the exact first occurrence of the word as the expected output is case sensitive. Okay, I see. So the first occurrence stays. Gotcha. Is this what I think it is, where they're only consecutive words? In other words, is this just really poorly written such that cutoff score? What does that mean? Is there there's a cutoff score? How do you not get the full score? Oh, I think I get it. Like, you can get part of it. There aren't any examples where there are words in between other words. I think this is really badly written and really confusing. These are repeated words, not... Oh, man. That's not a 0, by the way. That's really frustrating. This is much harder if you're talking about, like, duplicates throughout the entire string, not just proximally duplicate values. That's so confusing. I actually think I need to check the discussion to find out if I don't understand the question. I don't want to read the answer. Unintelligible explanation. Didn't spell it right. You married, I am. Yeah, this is the one that I confused. Repeated words that are directly next to each other, the output is... Yeah, see, that's what I'm talking about. I didn't understand the question the first time I read it, because I was like, oh, it's really hard to do if you're just using a regex. It's only the ones that are next to each other. Problem statement is unclear on exactly what to do if a word appears multiple times. Another word in between them. Yeah, this is what I was looking for. I thought so. It's actually a much easier question if you assume. Okay, well, kind of like cheating to read like that, but yeah, it's only the ones that are repeated to the side. Okay, otherwise it's way too hard, I think. So yeah, if there's a, so how do you get all of the other oh yeah, you do it this way. So you can get so you get a token or a string, and it's got to be either have something to the left or it's at the beginning of the string, and you get one of these. And then you can match any number of times the following so this is going to be group 1, and there could be any amount of space between this string and group 1, and this can happen any number of times. So you have repeated, you have this repeated a few times, and what you're going to do is replace this regex, which is really just what was matched, M group 0, and you're going to replace with M group 1. Something really simple like this. And you don't really need the dot all, you just need case insensitive. Excuse me. I really need to go to sleep. Yeah. Okay, I see the problem. One of the reasons I don't really like Hackerrank that much is because you can't use the excuse me, you cannot use the code, I guess the editor or the system. You can't use the website to run test cases to get the output, the expected output for those test cases. Excuse me, in order to get more clarity on the question. Which, if you were in an interview, you can ask the interviewer, and if you were for clarification, obviously, if there's no interviewer to ask, then you would want to use the test cases to find out. So I don't really like Hackerrank for that reason. I prefer to use LeetCode. I think it's better for that, at least. Oh, and then in this case, you want to do, yeah, actually that's the correct. Okay. What happens if we do this? Goodbye, bye, world, goodbye. Final output, goodbye. Okay. So this isn't matching anything. Group 0, hello, group 1, hello, group 2, null, group 3, hello, group 4, hello, final output, hello. What is group 1 in this case? Is it maybe group 2 that I should be looking for? So this doesn't match anything. Not sure if I should be using a look ahead or something. Really don't know. So this didn't match anything. What are these that get matched? Goodbye, goodbye, goodbye. So group 0, group 1 is goodbye, group 2, group 3 is goodbye. So I think it's group 1, and then if you have not sure what happened there. If you just have some other group here, which there could be any character at all, I guess. What does that look like? Okay, group 4, still group 0 is goodbye. Should be goodbye with the space, I think, right? Yeah. And this space here. But the question is, oh, it's the 4th group. I think the groups are read left to right. So really it really is group 1 that we're looking for. Yeah. And we're basically looking for, so if we had like goodbye a few times, right? So we did goodbye a few times here. Okay. Goodbye, goodbye, goodbye. Bye, bye, bye. Okay, so this matched. That's pretty good. One goodbye. So there we go. But then that was the final output, right? We didn't match anything more after that. We didn't match bye bye. Which is really strange to me. I think because I think it's group 3 we're supposed to be matching. Or group 1, I don't know. Don't know why this didn't match bye bye at all. Oh, that's why. I know why. That's the issue. That's confusing as all heck, but that's why. There's this 5th group here. If we go here, so we should have this bye 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 should show up. This first case, all the way up there. Good goodbye. Right, so group 0 is bye. And then there's group 1 is bi, group 2 is bi, group 3 is bi, and this other one is null. And this is what we're trying to match. Actually, it's this group 3 that we want, which is kind of interesting. And this other one's group 4. It's confusing. How do we get just this one here? Really do just want this is really confusing. Well, there's no replacement to replace here. So what the problem we run into is this doesn't work. We more or less want to tokenize our string . I mean, you could do something like this. But it doesn't make sense. There's any amount of white space. And then there's this first token here. It's pattern. So this first one doesn't match anything, but this goodbye does. Now the thing is, we just want, could be this guy, or it could be another string. Can we do it like this? Okay, from the top. But see, that's the problem, right? We shouldn't be bi. World. By world, and then this is close. It's getting closer. It's the idea, but this one needs to have at least one white space character in front, and we still want this, the first group. But the problem is that this ends up being white space, which we don't need the white space in our matching here on this side. That, I think, is kind of a problem, kind of an issue. We actually want to throw out this white space. So really, we need an expression to pick from either this one or this one. We could maybe trim the white space and do it that way. So this group 0 is the whole thing. It's not really the group 1 we want to trim group 1. So we can do maybe that's what we want, something like this. Okay. So it's goodbye, bye, bye. It just doesn't get there. We get the goodbye, goodbye, goodbye. But then bye, bye, bye gets untouched, right? For whatever reason, bye, bye, bye just doesn't make it. And that doesn't make any sense to me. Why wouldn't you get this bye, bye, bye get picked up here? That is so confusing. I'm so annoyed. How come? But this one will get. Okay, let's do it this way. This one will get picked up. By the, this one will pick up bye, bye, bye. Oh, how did we do that? No, what, really? Come on, man. You kidding? Any number of non-white space characters followed by any white space. Maybe, I mean, how? Oh, this actually doesn't need to be. That's maybe why. There we go. That's a lot better. Okay. Bye bye gets picked up. Group 1, Group 2. Goodbye, goodbye, bye. World, goodbye. That's really interesting because this gets just replaced with no white space because we trimmed it, right? We don't actually want to trim that, do we? We don't. Not actually what we want to do. Okay. Bye bye world, goodbye, goodbye, bye world, goodbye, world, goodbye, bye world, goodbye, goodbye, bye world, goodbye, comes goodbye, bye world, goodbye, oh, was I doing this wrong the whole time? What is going on here, man? Oh, I see. Okay. Well, this could be or the one that's this is a lot better, but this could be or this guy here. Yeah, that's what I was doing wrong. I just didn't have I had too many spaces here. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . bye, bye, world, 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 goodbye. So here we get bye, bye. Then we get world, world, world. Okay, we get goodbye 3 times. That ends with goodbye. We get bye, bye. World, world, world. Okay. I think this is what does what we're supposed to do. Hello world, hello is just supposed to be what it is, and okay, I think we got it. It took forever, but I think that's where we need to be, so yeah, this first expression, we are supposed to take the white space, and the reason that we take the white space is because when we replace this at the end, we want to keep that white space. The tricky thing though is there could be any amount of excess white space beyond that. It's like it's really confusing. It's like, I guess everything beyond the first occurrence gets removed, right? So any amount of white space, all that stuff, it just all gets removed. But the first one we keep. But the thing that's confusing is, I think this should be, see, that's the thing that's tricky. I actually think this should be, this white space should be like not really considered. So I guess it depends on how the problem is stated. Excuse me. Yeah, see, that's probably the problem. The biggest problem is that the white space characters, how many there are. If they're only space separated by a single space, this is much easier. But if they're like, if the first instance has a lot of white space between it, right? Like this will fail in cases where, like if we did something like this. And we said 1, 2, 3, right? So in that third test case, the final output is the first test case, the final output is the second test case, but here's this test case. We match here. Oh, really? Wait, what? Oh yeah, because we match here, but if we, I don't know. But if we added, it won't work properly in this case. 1, 2, 3. Yeah, see that? Oh, wait, what? Wait, really? This bye-bye. Oh, that's interesting. So it did match just a single white space character. Huh. wonder if you could do this. Oh, start matching the wrong things, right? Start matching oh. Goodbye becomes godbye. Bye. Yeah, you need. Right, I think you need at least one. You need at least one white space character. But again, that doesn't really work properly because you could have other white space characters separating each of these. I think there are test cases this fails on, even though this looks pretty good. Because you could have tab characters. So if we did bye with one tab character, right? That would be a test case that this fails on. Because what happens is, if we do bye and we say tab, right? Because the problem with this is, the problem with this is, even though it'll match here as the initial value, there's this other white space. This one white space character doesn't match the single white space character used here to identify this in the first place, which is kind of a problem. Yeah, you see that? This bye just skips right over. So we don't touch that bye. That's not good. That's technically not correct. And how can you avoid that? That's very tricky. Very tricky. Yeah, that would be like the fourth thing to match. Oh, you know what you can do? I have an idea. We can do 4. That's fine. 1, 2, 3, right? Well, this is really 1, 2, 3, 4. We can do 1 or 4. How about that? There we go. Now we got this one, the bye. Now we're handling that case. Hey, sweet. And actually, there needs to be some amount of white space here. Let's see if that still works. Goodbye. Bye. World. Beautiful. Gorgeous. So bye-bye, world. There you go. Alright, so I think we got it. I don't actually know. We want to get... Yeah, group 0 just gets replaced with group 1. But we want to match correctly. So I think this is what we want. It's real simple. This pattern is not that simple, but simple enough, I guess. And then we want just, yeah, group 0, group 1, like so. I really gotta go to sleep, man. Processing. Wrong. What? What? We were so close. We were so close. What is this? What's going on? Wait, what? 1, 2, 3, 4, 5, 6, 7. Why do we get 6? In. Oh no. These need to be whole words on the right side as well. Okay. So these are, this doesn't matter as much, but yeah, there's got to be at least some white space, and then it could be the matching word, and it's anchored toward the back, or we want to group that together, or it could be the matching word and there's some white space. Following. That is quite the regular expression, man. Okay. Yeah. All right. So that just make sure that all the way on the right side, we make sure we match a full word. Always matching full words. This is quite the regular expression. There might be a better way to do this, but I don't really know of it offhand. Or maybe at the moment, a better way of saying it. Let's see. Do we get all these test cases? Let's see how we do. May or may not actually get these test cases. Nope, still wrong. Okay. Oh yeah, because we're matching the space in between now. No, man. No, no, no. 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 Don't want to actually match that extra space off to the side. Well, that's interesting. Oh boy. Trying to make sure that we match full words and only full words. How do we do that? Excuse me, we could use look ahead. Positive look ahead. Which I think is just x equals something like this. Whoops. Question mark equals, right? Positive look ahead. It's not a part of the equation. Oh man, this is so involved. Seems to do the trick. Make this a look ahead. Oh man. This is like, okay. See how we do. Hey. Alright, let's go for it. It's probably not correct, but we can try it. Oh, we got there. Wow. Heck yeah. Alright, well, good stuff. Or good job. We did it. I shouldn't say heck yeah, we'll just say we did it. Alrighty, got our 5th star. Great. Great. 22 out of 64 challenges solved. Alright. Get certified in Java. Sweet. Let's get the certificate. Sweet, I'll do that. Okay. So we still have quite a few Java programs. We have 42 more Java questions to solve. Brother, this was crazy. This is way too much. This regex pattern, this is ridiculous. This is the most ridiculous thing. Maybe this should have been a negative look behind. Excuse me, I think if I made this a negative look behind, this would have been a little bit better. Negative look behind, or just look behind, or the positive look behind. sorry, positive look behind, and then this could just be a dash dash 1 instead of dash dash 4, and then it could be also yeah, so this thing would have been quite a bit simpler if I did that. Have the look ahead and the look behind. Yeah, I think so. I think so. Yeah, but anyway, so this works. Great. Let me. That was quite the problem. That was so involved. I think, yeah, there were so many issues involved there. One of the big things was just knowing what they mean by duplicate words in the first place, right? That was kind of a big deal. And then, yeah, knowing what they mean by duplicate words in the first place, and then like finagling with that, wrangling with that regular expression to try to get that to work. Like, it's quite the regular expression there. All right, I'm gonna go. So thank you all for watching. Talk to you soon. Appreciate it. I don't know what to say here other than, yeah, I think the plan is to go ahead and finish the Java like sequence on Hackerrank, and then get back to the leak code problems and do some of those in Java also, so I have C++, Java, and C++, Java, and yeah, I'm upset because I interviewed in Java for Java or in Java for a position, and basically didn't work out. Didn't work out. So I need practice. So we'll do more Java program problems. Yeah, I want to do more of that, and then we also want to finish the leak code problems, do all of those. And that's probably it for a while. I mean, I don't know. That's gonna take a long time. Well, okay, yeah, let me go. So thank you for watching. Talk to you soon. Have a good rest of your day.